On your quantum theory notes, you should see a box at the right-hand corner that says the rules. I'm going to give you a set of things to copy into that. They're not going to make any sense to you at this point. And then I'll explain in a sequence like what each one means, and we'll spend some time practicing some application of those in the Bell work and assignments in the following days. All right, but here's what you write. First, you're going to write the letter N equals, and then 1 and up. These are all going to be whole numbers. So we start with the number 1, so then it would be, the values can be 1, 2, 3, 4, and so on. The second thing, you're going to add a total of 4, just so you know how much space to use up. The second letter that we're going to be concerned with is the letter L, lowercase, just like the N. And the values for L go from 0 to n minus 1. So the value for L depends on whatever your value for n is. So if n is equal to 2, then L could be from 0 to 1, because 2 minus 1 is 1. If that's not making any sense to you, it's okay. Like I said, we'll apply this here shortly. The third value you're going to add is the letter M. All of these are lowercase. And M has values, okay, I don't know what I just hit, but that was not good. Okay, there we go. Sorry about that. M has values from negative L through positive L. So it's kind of like on your number line. If L was equal to if L is equal to 2, then M would be negative 2, negative 1, 0, positive 1, positive 2. So whatever the value for L is, M starts at negative that number and goes all the way up your number line to positive whatever that value of L is. The final one is S, and this only has 2 values, positive 1/2 or negative 1/2. So that's what should be in the box entitled The Rules. Back to our notes where it says quantum theory. It's a mathematical description of electrons. Now, by mathematical, just the numbers that you put in the box. So it's small, whole numbers, some negative numbers, and 0, but we're not talking about fractions, decimals, or anything very large. So it's not difficult, but it's completely new to you. So it's going to seem a bit odd, probably, at first. The word orbital, we're going to use that a lot as we talk about quantum theory, and that is a space that can occupy up to 2 electrons. Now, it can be empty, so elements can have empty orbitals in their electron clouds. They can also have orbitals that only have 1 electron in them, but once an orbital has 2 electrons in it, it is completely filled and no more electrons will fit. We're going to watch a little clip from my favorite professor about orbitals.
This word is orbital. It is about how electrons orbit round the nucleus in an atom. Now, we used to think, Rutherford's time, that the electron went round like the Earth goes round the Sun. But in fact, you can't treat it like that, because the electron is all over the place. Behaves like a wave. You can't tell exactly where it is, but you can tell the approximate volume that it occupies. And the volume has a really funny shape. And they're different shapes that are important for different atoms. In fact, it's these different shapes that give the periodic table its whole structure. The simplest shape is called an s-orbital sphere. Then there are 3 orbitals called p orbitals, which look like this, which have 2 blobs with a nucleus in the middle. One pointing upwards, once pointing towards you, and the third one, if I don't drop it, pointing out of the door. The third sort are called d orbitals, which have 4 blobs, which can point in 3 different directions. So we have 3 like this. And then we have 2 more. I'm running out of hands. One which looks like this, and the final one looks a bit strange, called dz squared. Looks like a disk threaded onto a dumbbell. There is a 4th thought called f orbitals. There's 7 of them. too complicated for me to afford the models. And with these orbitals, you can explain the whole structure of the periodic table. S and p orbitals for the main group elements, hydrogen, chlorine, and so on. D orbitals for the transition metals, iron, copper, nickel, and the F orbitals for the two rows at the bottom, the rare earths and the actinides. This is short, very simplified, but the idea of orbitals is absolutely key to chemistry. You can explain how atoms bond together to make molecules. And chemists use orbitals every day. Mendeleev, who devised the structure of the periodic table, didn't know about electrons, hadn't been invented. They were discovered just before he died, but he never believed they were important. But we now know it's the key to the whole periodic table.